probably seen some recently. There's over 600 around Flagstaff. Now these are an anomaly because most volcanoes form at plate boundaries where dense ocean crust collides with and is pushed down beneath lighter continental crust at a feature called the subduction zone. As the crust sinks, it melts the surrounding rocks, creating magma that rises to the surface to form volcanoes. The Cascades of the Pacific Northwest are an example of this process in action today. Subduction zones are important to study for several reasons. First, for the hazards they pose. Just look at Mount St. Helens in 1980 or Fukushima in 2011 for examples. Second, subduction zones create precious metal deposits such as the copper of southern Arizona and help regulate ocean chemistry by subducting minerals partially formed from ocean salts. Lastly, the forces of the sinking crust and the added weight of volcanoes on the surface form basins that accumulate sediment and preserve a long-term geologic record. However, many questions remain about how, when, where, and why subduction zones originate. Their early history is erased by later deformation, volcanism, and erosion. Subduction seems to have begun beneath North America around 275 million years ago when all the continents were assembled into the supercontinent Pangaea. The volcanoes from this time have eroded away, but evidence of their existence remains as remnants of their magma chambers, shown by the red triangles on the map, and as volcanic sediments that accumulated in adjacent basins. By traveling to multiple mountain ranges throughout the Southwest, hiking miles to the desired outcrop, and collecting samples of sandstone from these ancient basins, I can learn about the early history of Western North America's earliest volcanism. How? Well, all sand is composed in a small percentage of the mineral zircon, pictured at center. And even though each zircon grain is less than 0.5 millimeter long, pardon the grainy photo, its age and chemistry can be used to inform geologists about the timing of volcanic events and the type of lava involved. By extracting hundreds of zircon grains from each of my 10 samples, I will gain major insights into the earliest subduction-related volcanism beneath Western North America. The results of my study will help inform geologists about an enigmatic time in North America's history and will help provide insights into processes that may occur at modern incipient subduction zones, such as the one forming just southwest of New Zealand. Thank you for your time.